So,
Hello.
hello, Mr. Henry, Mr. Ryan. How are you today?
Good.
Okay, so today we talk about an interesting problem which you may seem familiar, later, which is called climbing the stairs.
We climb the day
Okay.
using dynamic programming.
We
Yeah.
don't climb up the stairs, we walk up.
Okay, so look, how many stairs are there? Can you count? How many stairs?
1, 2, 3, 4,
4,
5,
6, 6, 6.
Okay, so that's 1, 2,
And there's
3,
21
4,
blocks.
5, 6. Okay?
21 blocks.
Climbing stairs. Climbing stairs. So listen carefully. Okay. So now you are here.
There's a line there.
Yeah, that's okay. You are here. So you are here, yeah? You are here. So every time you can climb one step or two steps. So you can first
The
you can
steps are nearly bigger than.
yeah, that's okay. You can jump here. This is
Yeah.
one way, and you can jump to two here. Yeah. Okay, got it.
Yeah.
So you can jump here or jump here. That's it. No more jump three. If you want to jump three, you have to jump here and jump two, or jump two and jump one. So basically, you can jump maximum 2 steps at a time. Okay. So the question is, to get to these, how many ways can you do it? So for example, look here. You can.
Two.
Maybe if 6 is a bit more. Let's do it like 4. Okay. If it's coming at least 4. Okay. So look, you can do this 1, 1. So it's 1, 2, 3, 4. Okay. 1, 2, 3, 4 each time at a time. Or you can do this.
One.
You can do 1. You can do 2 and 4. Okay. Or you can do 2, 3, 4. Or you can do 1, 3, 4. Okay. So how many ways? Or you can do
I see 4.
1, 2, 4. Okay, 1, 2, 4. Yeah, that's it. Yeah, 1, 2, 4, 1, 2, 3, 4. 2, 4, 2, 3, 4. Right? 1, 3, 4. Okay, so there are 5. Got it. Got it. Yeah? Yeah? So any idea how can we achieve this kind of problem? Remember yesterday we talked about what's that? What did we talk about yesterday? Dynamic programming to count the number of ways to walk in the grid from the top left corner to the right bottom corner. Yeah. In order to reach the right bottom corner, and where could it come from? It's similar. Where could it come from? Look, imagine the grid. This is the target. This is the destination. So before the destination, where how many possibilities of these previous locations? How many?
If it's a 3 by 3.
Yeah. For example, you are starting at this point. You can only walk south, or walk east, and walk south. And to reach this destination, what possible location can it be before reaching this destination?
This and this.
Yes, well done. 2. Okay, so look, this is the way to think backwards. You see, think backwards. So in order to reach this position, you can reach here or here, right? So the solution will be the sum of these and these, right? That's why we roll a dynamic programming equation. Fnm equals Fn minus 1m plus Fn m minus 1. Got it?
Yep.
So for this one, I'm at stair n. So where possibly the previous location?
The one before or 2 back.
Well done. Okay, so suppose this is Fn. So it could be coming from Fn minus 1 or Fn minus 2, right?
Yeah.
And what's this? And how many answers would this be? So is it simply equals this plus this? Alright?
Yeah.
And what's this? What's this? We talked about this before. The one start with F. What's that?
Fibonacci number.
Yes, Fibonacci number. Okay, so look, in order to get here, you need to get here or get here, right? Yeah? And then what's the terminal condition? Which is F1 equals 1, right? Because in order to reach 1, only one way, right? Yes? F2 equals what?
Before or the beginning.
Yeah, so how many ways to come here? You can jump 2 or you can jump 1, 1, so it's 2, right?
Yeah.
Okay, so that's it. Fn equals Fn minus 1 plus Fn minus 2. This is dynamic programming. Got it?
Yeah.
Yeah, got it? Because we save this value. We need to save the value by implementation, okay? So do you get it, right? Right? Do you get it? Yeah? Look, in order to jump to this point, you have to jump here or jump here, yeah? Because here is 1 step and here is 2 steps. Alright? You think it backwards, yes? Yes? And then look, Fn equals Fn minus 1 plus Fn minus 1. What's that? Fibonacci number. Got it? Okay, so now we can just implement it very easily. Look,
1, 2.
be fine, but the starting point will be a little bit different because Fibonacci number, the first one is 0, 1, and then here is first one is 1, 2. Okay, so a little bit shifting, but it's basically the same. Okay, Fn, what's missing? Okay, then look, if n equals 1, return what?
1.
1, okay. If n equals 2, return 2. Otherwise, return what?
F. N. Minus 1. And F. N minus 2.
Well done, well done,
Well done.
well done. Okay, so this is basically the Fibonacci number, except these values are slightly different, okay? This is recursion. Remember, we talk about recursion. This is inefficient. The time complexity of this one is what? What? Look, remember we talk about this and the tree, each one has 2 possibilities. How many possibilities will that be? Yeah? O over.
N.
Why is n? Why is n? Not yet, not yet. Look.
I haven't finished the sentence yet.
Okay, look. F3 equals F2. Again, F1. Okay? F2 equals F1 plus F0. Okay?
Yeah.
Look, F1 calculate multiple times. Again and again. Remember this tree. Yeah?
That's N O N square.
No, because 2. Each n corresponds to. So it's O to the power of n. This is very inefficient. But we can put something to speed up to make it on. Yeah, what's that? Because we want.
This must be slow.
Yeah. So how can we speed it up? Using a.
Notebook.
Yeah, using notebook. Remember, we talked about this many times. Notebook. Yeah, notebook. Okay. And then now look up. If n in notebook, yeah, return notebook n, right? Otherwise, value equals that, and the notebook n equals, and put a value into the notebook, and then return what?
Value.
Value, yes. And look, we don't need to implement this notebook manually. We can just erase it, yeah. Look, we can just erase it. Remember the magic keyword, remember?
Yield.
Add ARU cache, yeah?
Cache.
Cache, this is a cache, but from Python 3.9, you can remember this shorter one. Add cache. That's it. Simple, right? So if you put this in front of the function, and it tells the computer to memorize, to automatically use a notebook to memorize these values given an n, right? So for example, if you calculate f5, and the next time you're asking for f5, it will automatically retrieve it from the cache, yeah? Yeah, instead of calculating it again and again, right?
Yeah.
Okay, so this complexity is what? I just said it before.
N.
Oh, n, yeah. Because if you want to calculate fn,
Shouldn't you do a catapult?
that's fine. If you want to calculate fn, and then how many values you just need to calculate? Fn, Fn minus 1, Fn minus 1. Each value from 1 to n, you only calculate once, right? Yes?
Yeah.
So that's how we make it Fn. This is called top-down dynamic programming. Yeah, because we want to calculate Fn. So we calculate Fn minus 1 and Fn minus 2. In order to calculate Fn minus 1, I calculate Fn minus 2 and Fn minus 3. Okay? But Fn minus 2 I have calculated, so this one I don't need to calculate it again, right? Top down. How about bottom up? Yeah, we talk about that as well. Bottom up. So in order to calculate Fn, right? So I can calculate F1 and then F2 and then I calculate F3 and here I get the Fn, right? Yes? Yeah, this is called what? What's the opposite of top down?
Bottom up.
Bottom up, yeah. Because look, you're calculating from the bottom, F1. Okay, so how can we do this? Look, A, B equals 1, 1. Okay? For I in, you don't need the I, for in range 1, n. And then what do we do here? A, B. What's the new A? What's the new A? This is A, B, and I want to shift it here, become A, B. What's the new A? What?
B.
B. And what's the B?
C.
No. What's the B? What's here?
B and 1.
Sorry?
B.
What's here? A, B, and what's next?
C.
What's C?
B.
Fn equals Fn minus 1 plus Fn minus 2. So what's C? Fn equals Fn.
Fn. No, F.
So what's C? What's here? What's you put here?
F and FB.
This is A, this is B. So what's next?
FB minus 1.
No, this is A, this is B. So what's this? This is A, this is B. So what's this?
C.
There's no C. This is A, this is B. What's this?
N. N.
What? Come on. This is A, this is B. Look, this is 2, this is 3, this is what?
4.
Fibonacci number.
5.
5, yes.
Yeah.
So what's this? This is A, this is B. What's this?
S. A plus B.
Yes, I'm looking for this A plus B. Why is it so hard? Okay, and then return what? Return B, yeah? That's it, return B. So, which one you think is better? This is bottom up.
Well, I don't know.
Bottom up. And remember, we talk about cache, okay? I'm implementing again, okay? Define Fn. And I show you, okay? If n equals 1, return 1. If n equals 2, return what?
2.
2. And return what? F what?
N minus 1. F n minus 2.
Okay, so this is top down. This is bottom up. Okay, so this one, in order to calculate Fn, I calculate backwards. Fn minus 1 plus Fn minus 2. This one, in order to calculate n, I calculate from F1, F2, F3, F5. This is bottom up. Okay? So which one you think is better? It depends on how you like. Yeah, it's the same. Both complexities is On, right?
Yeah.
Okay? So, any questions so far?
No.
Interesting? Okay, you can say see you tomorrow. Bye bye.
Bye. Bye.
Bye bye. Bye bye.
Bye.